Good morning, chat. Welcome in. My name is Penbu. I am the programming, puzzle gaming, and music making VTuber on Linux, and today we are doing programming. We're going to be learning the front-end framework called Svelte. As the title, actually, before I get to that, how is everyone? I always forget to ask. Always dive right in, but it's important to interact and treat you people as people. Anyway, today we're learning Svelte. As the title says, I am a React dev. I don't actually like React, but it's what I have a job in. Thankfully, I don't really have to write it anymore, since I am no longer really hands-on keyboard development, but rather overseeing projects. But I do have to interact with React every day. I figured if you were following along with the Owl Fudge project, and if you're not, there are two videos on my channel. Go have a look. Long and short, we're creating an esoteric programming language called Owl Fudge, inspired by FaZe Connect's VTuber Jelly Hoshiyumi. And one of the things that we're going to do with it is a web page where you can put some code in and it spits out code and it interprets it for you. And I figured we would write that in Svelte because it's much easier to create a web app with the front-end toolkits rather than without. For example, my website right now, the schedule, is written all by hand with handmade templating engine of sorts that's doing all raw DOM manipulation. It's not great, and I did want to rewrite that in Svelte at some point, but the problem is I don't know Svelte, and I didn't want to use React, so here we are learning Svelte. And the reason I choose Svelte is because to me it resonates more than the others. It used to be that Vue resonates with me, but then I found Svelte and I found that it resonates with me more. And so what is it? At the very basic level, if you don't know anything about front end, at the very bottom you have like HTML, CSS, and JavaScript. Those are what's running on your browser, and then on top, you generally have a front-end framework, either React, Vue, Svelte, Riot, what else is there? Something like that, a front-end library that lets you create HTML programmatically. So it allows you to make your code a little bit more modular and build out parts of your page in a way that you can just piece things together. Those are called components. I guess, yeah, they're called component libraries for a reason. And so Svelte is one of those. We have compiled. Svelte shifts as much work as possible out of the browser and onto your build step. No more manual optimizations, just faster, more efficient apps. This is already one thing that's very different about Svelte, because most of the front-end libraries like React and Vue, they're all running at runtime, so the browser is doing all of the all the manipulation and building and all that. Whereas Svelte, the browser is still doing manipulation, but most of the work to do that, to figure out what needs to be manipulated, is already done at compilation time. Compact. Write breathtakingly concise components using languages that you already know. HTML, CSS, and JavaScript. Oh, and your application bundles will be tiny as well. Large bundles is one of the things that I don't like about React, and so it's really nice that Svelte compiles really, really small. I generally browse the web with JavaScript mostly off, and so I do, in part because there's a lot of JavaScript bundles can get pretty large. And so I do appreciate it when you have a small amount of JavaScript to download. I mean, with network speeds this fast, it doesn't really matter. But you do have some people, like people on their phones, or people on metered connections, or say in rural areas where speed isn't so fast, and people do tend to forget about them. So keeping things small is better for everyone. Complete. Built-in scope styling, state management, motion primitives, form bindings, and more. Don't waste time trawling NPM for the bare essentials, it's all here. If you saw my first programming stream, I had taken an NPM meme to an extreme where we had written FizzBuzz with as many NPM packages as possible. With React, I do find that in NPM or node development in general, you do find that you do start looking for packages to be able to do stuff. But of course, with the more packages that you have, the more surface area you have for bugs and security issues. So the smaller your dependencies, the better. See for yourself. We will be doing the interactive tutorial in a bit, so we'll go and do that. And these aren't really going to mean much until we get to the tutorial. I'm going to skip over that. And the framework is used by a lot of like well-known brands. All of these people. And of course, big team. It is an open source project, and you can contribute to it, and it seems many people have. Also, donations. Not sponsored, by the way. I just, I think Svelte is having no practical experience in it, just from its description and what I've heard about it. I think it's really nice. But we will see as we start learning. So, this tutorial leads to this this tutorial here, and so we're going to be going through that. And it is interactive, so feel free to follow along if you'd like on your own. The link is in the description. You know, it's funny, when I started, I figured I wouldn't do a lot of learning streams because I have watched a few learning streams and I did find that they were kind of boring. But I think what makes a learning stream fun is if you can do something and then see it in action almost right away. And an interactive tutorial really helps with that. So hopefully this will be interesting. But even if not, you know, this is groundwork for work that we're going to need in the future anyway, so it won't go to waste. So, welcome to the Svelte tutorial. This will teach you everything you need to know how to easily build web applications of all sizes, with high performance and a small footprint. You can also consult the API docs and the examples, or if you're impatient to start hacking on your machine locally, create a project with npm init svelte. We may or may not get to this today, because if you look at the tutorial, there are 4 parts, and that looks like a lot of content. What is Svelte? Svelte is a tool for building web applications. Like other user interface frameworks, it allows you to build your app declaratively out of components that combine markup, styles, and behaviors. Declaratively means that you basically just say what you want. Make this a little bit bigger, I guess. And that's very nice because it means that you don't really have to think about how you're doing something. You let the system do that for you. And that means that maybe the system can be more optimized, and the system, or rather your code, is a little bit easier to reason about because you don't have to think about how you're doing something, you just think about what you need. These components are compiled into small, efficient JavaScript modules that eliminate overhead traditionally associated with UI frameworks. Yes, we talked about that. One of the things that I didn't mention was the virtual DOM. And so React and Vue and a lot of the other front-end frameworks, what they do is they have a copy of the tree in memory, and they do operations on that tree and then reflect those changes in the browser DOM itself. DOM being the document object model. It's it's the tree of tags, tree of elements that you see rendered in the browser. Whereas Svelte, what it does it uses the browser DOM directly instead of managing its own DOM. And that resonates with me a lot because the browser is there doing its thing. Why wouldn't you use it? There are some libraries that work with VDOM and I guess sometimes they can be helpful, but you can build your entire app with Svelte, for example, using an application framework like SvelteKit, which this tutorial will cover, or you can add it incrementally to an existing code base. You can also ship components as standalone packages that work anywhere. And I believe this is talking about web components, which is built-in solution for this kind of thing that the browsers natively support. There are some issues with it. It's not quite to the same level as these third-party framework solutions, but they can be useful. I have worked with them before. They're nice, but I don't know. I have some issues with web components too. How to use this tutorial? You'll need to have basic familiarity with HTML, CSS, and JavaScript to understand Svelte. I have more than basic familiarity, but perhaps you might not. That's okay. I'll try to explain as we go along. This tutorial is split into 4 main parts. Basic Svelte, you're here, it's Advanced Svelte, Basic SvelteKit, and Advanced SvelteKit. Each section will present an exercise designed to illustrate a feature. Later exercises build on the knowledge gained in the earlier ones, so it is recommended you go from start to finish. If necessary, you can navigate via the menu above, which we have seen. If you get stuck, you can click the Solve button to the left of the editor. The Solve button is disabled on sections like this one that don't include an exercise. Try not to rely on it too much. You will learn faster by figuring out where to put each suggested code block and manually typing it in the editor. And that is something that so I had gone to a co-op program, and one of the places that I went to had mentioned that you shouldn't copy and paste code when you're learning. You should type it out. And that's so that you start putting it in your muscle memory. And when you type out code, you really have to think about what it is that you're typing, or you should be thinking about what it is you're typing. And that lets you be a little bit more critical and maybe remember it better. Next, your first component. In Svelte, an application is composed from one or more components. A component is a reusable self-contained block of code that encapsulates HTML, CSS, and JavaScript that belong together, written into a .svelte file. The app.svelte file, open in the code editor to the right, is a simple component. We have app.svelte, and its source code out here. And its contents are an h1 element wrapping a hello world text, rendered down here. Adding data. A component that renders some static markup isn't very interesting. Let's add some data. First, add a script tag to your component and declare a name variable. We're going to do what this says. We're going to add a script tag. And we're going to let name equals Svelte. Kind of wish I had Vim key bindings here, but I'm going to have to put up with that. Then we can refer to name in the markup. Hello name. Just like that. So name here is a variable. A variable is basically a container where you can hold data. And variables have names, and this one is called name. Usually you want to name things in a meaningful manner. And then we reference this variable here inside the curly braces. Inside the curly braces, we can put any JavaScript we want. Try changing name to name.toUppercase for a shoutier greeting. We will do that. Just like that. And toUppercase, of course, makes the text uppercase. Dynamic attributes. Just like you can use curly braces to control text, you can use them to control element attributes. Our image is missing a source, let's add one. So we have the source variable here, pointing to image.gif. I really do try to avoid saying that. Nice. And so we've added the source attributes and passed it the source variable. That's better. But if you hover over the image in the editor, Svelte is going to give us a warning, such as that. A11Y for accessibility. Image elements should have an alt attribute. A11Y, short for accessibility, is because there are 11 letters in between the A and Y. They do that for other things too, like localization becomes L10N. When building web apps, it's important to make sure that they're accessible to the broadest possible user base, including people with, for example, impaired vision or motion, or people without powerful hardware or good internet connections. Accessibility, shortened to A11Y, isn't always easy to get right. But Svelte will help by warning you if you write inaccessible markup. In this case, we're missing the alt attributes that describes the image for people using screen readers, or people with slow or flaky internet connections that can't download the image. Now let's add one. We'll add one here. Alt equals man dances. We can use curly braces inside attributes. Now that's interesting. This is not something you can do in React. You'd have to do this and then build a string inside. So this being able to do it inside is kind of nice. So let's say name dances. Remember to declare a name variable in the script block. So let's let name equals svelte like before. And then if we look inside here, we see Svelte dances. I guess we can change this to Rick. Shorthand attributes. It's not uncommon to have an attribute where the name and the value are the same, like source equals source. Svelte gives us a convenient shorthand for these cases, where we can just do this. And this seems really handy too. So in React, you'd have to do something like image. Well, you don't have this in React. It'd be nice to have this kind of shorthand. But if you want that kind of thing, then you'd have to do something like image spreads an object with source inside, which isn't pretty. And sometimes that's discouraged. I definitely haven't seen it in the wild. I only recently saw it in an article. It doesn't sound too bad though, if you do it that way. But I don't think it's pretty common. So next, styling. Just like in HTML, you can add a style tag to your components. Let's add some styles to the P element. We have our style tag here. We want to write our CSS here. We have our P element here. And then this is CSS, so we're targeting the P element. And inside are the properties that we want to give it. So color is golden rods, one of the colors, the CSS colors. Font family, Comic Sans MS. I wonder if I have that installed. I do. Cursive. Font family gives you the font face for the text. In this case, we're giving it saying that the preferred font is Comic Sans MS. And as a fallback, we default to the system cursive font. I'm going to give it a font size of 2em. 2em being 2 times the font size at this level. And there we go. Importantly, these rules are scoped to the component. You won't accidentally change the style of P elements elsewhere in your app, as we'll see in the next step. CSS, plain CSS is all global. So if you were to put this out in a global style sheet, then it would affect all P elements. But because everything is scoped, it's only local to this component. We'll go on to the next one, nested components. It would be impractical to put your entire app in a single component. Instead, we can import components from other files and include them in our markup. Add a script tag to the top of app.svelte that imports nested.svelte. And so we will do that. And we see here we have nested.svelte with another paragraph. And so add a script tag where we import nested from nested.svelte, such as that, and include a nested component. And now we're using the component that we imported in the markup, such as that, and then we see that it does indeed import it. Notice that even though nested.svelte has a P element, the styles from app.svelte don't leak in. And we do see this as a P element, and this style does not leak there. Component names are always capitalized to distinguish them from HTML elements. HTML itself is case insensitive. The XHTML is not. But modern convention says that HTML elements should all be lowercase. So I assume, just like a lot of other what do you call it, front end frameworks, you're expected to have HTML as all lowercase. Next, HTML tags. Ordinarily, strings are inserted as plain text, meaning that characters like less than, or left angle bracket and right angle bracket have no special meaning. But sometimes you need to render HTML directly into a component. For example, the words you're reading right now exist in a markdown file that gets included on this page as a blob of HTML. In Svelte, you do this with the special @HTML tag. Just like that. Warning! Svelte does not perform any sanitization on the expression inside HTML before it gets inserted into the DOM. This isn't an issue if the content is something you trust, like an article you wrote yourself. However, if it's some untrusted user content, for example, a comment on an article, then it's critical that you manually escape it, otherwise you risk exposing yourself to cross-site scripting attacks. This is going to be out of scope for this. I'm not going to dive into deep detail about that, but basically what it means is that you can, if you are vulnerable to an XSS attack, you end up potentially running users provided code, and that code could do something malicious, like steal your passwords or whatever, or your cookies. So we can put an add HTML here. And it's saying that the expression results in HTML. And in this case, we have string as a string that contains HTML. Yes, I can. Okay. It contains HTML, and it'll apparently plop it right in there. In React, you'd have to do something. Jump through a couple more hoops. It'd be something like dangerously set inner HTML or something like that, and then you'd put something in there, which makes it extra clear that it's dangerous. I don't mind this because you have to know that this is a thing, and to me it's plenty clear that that you are potentially vulnerable to that. But maybe I just know too much. Reactivity. At the heart of Svelte is a powerful system of reactivity for keeping the DOM in sync with your application states, for example, in response to an event. To demonstrate, we first need to wire up an event handler, and we'll learn more about these later. So we can give this an on::click equals increments, click counts, count equals 1 times all there. Inside the increment function, all we need to do is change the value of count. So we do counts plus equals 1. I'm going to delete this comment. Svelte instruments this assignment with some code that tells it the DOM will need to be updated. So we can click this and we get a counter now. If we reset to what it was before, clicking this won't do anything. In part because we don't have the handler. On click equals increment. But at the same time, we don't have any code in here that does any increment. So we can do count plus equals 1. But if we remove this, then it won't do anything because we haven't bound the handler to it, so it doesn't know to call increments. We need both. This differs from React in that React, you would do an on::click like that and pass in the function. I presume that the on:: is the way for Svelte to know that it has to do something special with it. And as it says, it instruments the assignment with some code that tells it the DOM will need to be updated. And also, this is another difference. In React, you would have to explicitly say that this holder, this variable or whatever, I mean, it doesn't really use variables, but you would have to explicitly say that this piece of data is state, and then by declaring it as state, it knows to re-render. And in this case, it seems like Svelte just knows that if this is updated, that it ends up being, or the component ends up getting updated as well. Or maybe it's because of this on. I'm not sure. We'll find out. But I do know Svelte does some sort of static analysis in the background while it's compiling, so maybe it just does know. Declarations. Svelte automatically updates the DOM when your component state changes. Often, some parts of a component state need to be computed from other parts, such as a full name derived from first name and a last name, and recomputed whenever they change. For these, we have reactive declarations. They look like this. So we have like count equals 0, and we have $:doubled equals count times 2. If a reactive statement consists entirely of an assignment to an undeclared variable, Svelte will inject a let declaration on your behalf. Don't worry if this looks a little alien, it's valid if unconventional JavaScript, which Svelte interprets to mean rerun this code whenever any of the reference values change. Once you get used to it, there's no going back. I'm sure there isn't. So a little sidestepping a little bit here, the valid if unconventional JavaScript is a labeled statement. And I'm going to turn on scripts here. If I refresh hard enough, it'll show it. Okay, whatever. So labeled statements, you don't use this very often, but it can be helpful. It labels a statement, whether a block statement or any other statement, and you can use it to break out of it, or continue if it's a loop. So, for example, just realize this is big enough. I'm gonna make it a little bit bigger. So, using label continue with for loops, you label for the first for with loop 1, and the second for with loop 2, and then on a certain condition, you want, instead of continuing the inner loop, you want to continue the outer loop, and so you can use continue with the outer loops label. So just like that. And similarly, you can break out of both loops as well. And so if you use break instead and give the outer loops label here, then it'll break out of both of them. And if you didn't have labels, you'd have to resort to flag variables, and that gets very messy. And then you can also use you can use break with a block. So if you label a block and then you break with the label, it will break out of the block. This is somewhat useful for keeping your variables contained, because constant lets are all block scoped. I don't see this ever. So in theory it has use. I haven't really seen it being used, because you can also just use a function. But anyway, the idea here is that Svelte is somewhat repurposing the labeled statements. And if you have the special label $, it takes it to mean a reactive declaration. So let's use doubled in our markup. Count doubled is doubled. So let's do that. And it says down at the bottom here, count doubled is doubled. And so we're using our count. I'm going to shrink this a little bit. Let me know if this is too small, by the way. So we're using our count, which was our state from earlier, which we're incrementing on the click of the button. And then we have a reactive statement, doubled equals count times 2. And so this is run whenever we need to do an update. So count here, we click, and then we trigger the on click, we run the increment, we increase it by 1, so this now has 1. And then we run this, where count times 2, count is 1, we multiply by 2. And then that gets sent to doubled, or assigned to doubled rather, which now contains 2. Which we then use down here, so 1 doubled is 2 is what we should expect. So we click and go through all that, and we get 2. Click again, we get 4, and so on. Of course, you could just write count times 2 in the markup instead. You don't have to use reactive values. Reactive values become particularly valuable, no pun intended, when you need to reference them multiple times, or you have values that depend on other reactive values. Note that reactive declarations and statements will run after other script code and before component markup is rendered. Statements. We're not limited to declaring reactive values. We can also run arbitrary statements reactively. For example, we can log the value of count whenever it changes. And so we can do that. $:console.log. The count is count. I assume that is the semicolon at the end, yes. You can easily group blocks. Actually, let's see what this does first. Is this the console? Yes, it is. So if we click, what we would expect to see is that when we click, it updates, it runs this code, it runs this code, and then it runs the reactive statements, and then it renders the component. So we click, then we should see in the console. Where is the console? That's a good question. Is it this console? Oh yes, it's this console. And you can't see that. So yeah, the count is 1. We click it again. Count is 2. And just like that. And so we can also group this with a block statement. Like that. And we have console.log. This will also be logged. Whenever count changes. And so, if we want to test this out, we'll open our console. We click. We expect both of these to show up. So the count will be count, so count will be 1. And this will also be logged whenever count changes. And so we see it here. You can even put the $: in front of things like if blocks. So if count is greater than or equal to 10, then we do this. And this is valid because this is in front of any statement, and an if is just a compound statement. And so, well, it says alert here. So let's do this. Count is dangerously high. And count was 0. So what are we doing here? We were saying that we increment count until we reach 10, and then we do a browser alert, and we reset count back to 0. And so we click until we get to 10. And when we click one more time, we expect to see the browser do an alert, and then we go back to 0. Just like that. Okay. So far, this seems pretty useful. Comparing to React, in modern React, you have function components, and everything inside the function ends up getting run every time you do an update. And that requires you to set up certain things like, what is it? Like use effects, so that you don't run certain codes when you don't need to. Actually, yeah. Well, let's keep it broad like that. Basically, with React, everything runs by default, and you have to be specific about the code that you don't want to run. Whereas it seems like in Svelte, things don't run by default, except for the things that you want to run, which is pretty valid, I think. And depending on how you write it, I guess that can be cleaner. So updating arrays and objects. Yeah, but even if it is that way, I think if you come from a mindset of everything runs, I think you do have to be careful about making sure that you do mark the things that you want to run. Otherwise, things might not work as you expect it to. Because Svelte's reactivity is triggered by assignments, using array methods like push and slice won't automatically cause updates. For example, clicking the add a number button doesn't currently do anything, even though we're calling numbers.push inside add number. We try that, we aren't doing anything. This array is probably filling up. One way to fix that is to add an assignment that would otherwise be redundant. Numbers equals numbers. We do see it's filling up there. I suspect that it has some sort of setter on this, and the tutorial did say before that it would instrument the compiled output with code that reacts on DOM changes. And I suspect that one of the changes that it does is put a setter on this kind of thing, so that it knows when something has been assigned to, or when this variable has been assigned to, and it can react on those assignments. But there's a more idiomatic solution. Aha! So we're taking the functional routes. So instead of pushing, we just create a new array. So we do numbers equals create new array, where we take the current numbers, spread them into the beginning of the array, and then appends length.1 or numbers.length plus 1 to it. So adding the next one onto the sequence. You can use similar patterns to replace pop, shift, unshift, and splice. Yeah, and even in something like React, the general expectation is that when you modify a value, the reference to that value should change. Or yeah, something like that. The reference. So you should be creating, if you're modifying an object that's passed in through props, or states, that you should be creating a completely new object. And it seems like it's pretty similar here, where it doesn't matter actually that it's a new object or a new array, but creating a new array in a functional style like this makes it easier and more idiomatic to do an assignment. Assignments to properties of arrays and objects. For example, obj.foo plus equals 1 or array at index I equals x work the same way as assignments to the values themselves. That is nice. So we have change that here. Well, actually, we should test this code first. We have that. That does work. Numbers.length. So we are assigning the last element of the array with numbers.length plus 1. Such as that. A simple rule of thumb: the name of the updated variable must appear on the left-hand side of the assignments. For example, this const foo equals obj.foo and foo.bar equals baz won't trigger reactively on obj.foo.bar unless you follow it up with object equals object. So this is interesting, because it means that you have to keep in mind what your assignments are, and how to assign. So as far as I'm aware, the general guideline for JavaScript is to use const unless you know you need to use lets, at least for modern JavaScript. And it seems like in Svelte, you use lets in a way to signify that you want to have this name here be state, and because you're going to be modifying it, and so it knows to trigger updates to the DOM whenever you assign to this name. Won't trigger reactivity on object foo bar unless you follow it up with. Okay. I think I'd have to see that in action to really understand that, but so why isn't this solving? What did it need? I think that was the same actually. Oh right, because we had changed it. That's right. Props. So far, we've dealt exclusively with internal states, that is to say the values are only accessible within a given component. In any real application, you'll need to pass data from one component down to its children. To do that, we need to declare properties, generally shortened as props. In Svelte, we do that with the export keyword, edit the nested.svelte components as so. So we export let answer. So we now expose or accept answer as a prop. And this is interesting. It's kind of like the extern keyword in C. Just like $:, this may feel a little weird at first. That's not how export normally works in JavaScript modules. Which is true, because normally you would use export so that another module can use it and import it, but this seems like it's more like exposing it. Just roll with it for now, it'll soon become second nature. And so we pass it in as props like this, just like we had with the other one before. Alright, so it's kind of like props on components are passed down similarly to attributes on HTML elements. So we're passing down a value of 42, which then gets put into answer, and then answer, because it's 42 from outside, now it has 42 here, and that is what's rendered on the DOM. Give me a moment, gonna have a drink of water. Okay, default values. We can easily specify default values for props in nested.svelte. So we go in here, export let answer equals a mystery. And so default value is a value that you get if you don't provide the prop. So in this case, if we now add a second component without an answer prop, we'll fall back to the default. Nested, such as so. And this is pretty useful because it means that you don't have to, for certain props where most of the time you want a certain value and only sometimes want to customize it, it's nice not having to explicitly pass it down. And it means that for the instances that you are relying on default, if you change that default once, then that gets changed for every instance. Whereas if you if you don't make it a default and force every component that uses it to supply its own value, then you might have to change it more than once, and that's prone to error. Oh, spread props. Actually, going back a little bit, comparing to React, in the modern form, with function components, you have a function, and then passing in as props. Let's put this inside of the JavaScript portion. You have a function, say components. It passes in as props, so prop, or say answer here. And then answer is just another variable that you can use. So it's pretty similar. It's just the way you consume and declare a prop is different. With Svelte, it seems like there's a little bit more syntax magic, I guess, that's happening. Whereas with React, it's basically just JavaScript, and then props are an argument to the function. At least in the function form. The class form, there's a props property that gets populated. Spread props. In this exercise, we've forgotten to specify the version prop expected by package info.svelte, meaning it shows version undefined. We could fix it by adding the version prop. Package info. So we can do version equals package.version. Then we have the version here, version 4. But since the properties of package correspond to the component's expected props, we can spread them onto the component instead. And so we can do this. Conversely, if you need to reference all the props that were passed into components, including the ones that weren't declared with export, you can do so by accessing $props directly. It's not generally recommended, as it's difficult for Svelte to optimize, but it's useful in rare cases. It's good that allows us to do that, because there is a difference between... So I find that when you're designing a system, you have to think about what the users can do and what the users should do. For your default design, you want to guide the user into what the user should do, but there are some cases that are completely valid that won't be captured by what they should do, and in those cases, you want to give them the capability to do what they want, assuming that it is something that's valid, and you want to be able to do it in a way that is still somewhat accessible, but in a way that's mostly in a way that it discourages regular use. So the easier way to do something should be the way that you want them to do it, but you still give them this other thing if the way that you want them to do it does not fit within their use case. What were we looking at? Packageinfo.svelte. Export name, version, speed, website. $href equals that. And so we have that there. And so this is the same as in React. If you have a variable and it contains props, they can spread that variable into it, or into the components, into the tag, and it'll do the same thing. And so spreading here puts a prop name, puts a prop speed, prop version, and prop website, as if you had written what we had before. Logic. HTML doesn't have a way of expressing logic like conditionals and loops Svelte does. And this is one of the big things about front-end frameworks, is that it allows you to do more advanced templating than what plain HTML does. This is the reason why you have things like PHP on the server side, where it allows you to do a bunch more advanced templating, or server-side includes, which do have loops. So you can loop through say a data structure and output, say, a list item for every item in that array. Or conditionals, for example, if you meet a certain condition, you want to render one thing, and if you don't, you either don't render it or render another thing. So to conditionally render some markup, we wrap it in an if block. Let's add some text that appears when count is greater than 10. So button on click increments. We do have this count again. And so we have a block. If counts is greater than 10, slash if. P counts is greater than 10. Update the component, click on the button. So I don't know how I feel about this the syntax here. This is basically what it looks like to be a directive. So it looks like Svelte has its own language of directives. And so I assume a directive is specified by an initial hash sign, and then there's a keyword after that. In this case, this is the if directive. And it seems the if directive takes an expression where count equals 10. This is probably just plain JavaScript. And then inside, if the count is 10, or if this expression is true, then we render the markup that's inside. And then we have our closing if. So I guess this is okay. It feels like you have to learn you almost have to learn two languages, but if you use this long enough, I think you'll get used to it. It definitely feels more template-y. I'll give it that. For something like React, where React puts itself as a JavaScript library, all you do is basically just write JavaScript. So it'd be a conditional, as it would be in JavaScript, so a ternary or an if statement. Whereas because Svelte, its templating is done outside of JavaScript, you can't really do that, it seems. So if count, so you have to. It seems that you have to resort to templating directives, which is entirely valid. But I suppose you can also maybe do something like this, where you could render perhaps a value, but that also sounds like it'll be somewhat unidiomatic within Svelte. So I suspect this is not like in React where you have JSX, and JSX is just another expression or another value. You probably can't do something like E whatever there, because it's not JavaScript. So, okay, that's interesting. Next, else blocks. I do wonder if this ends up being less flexible than something like JSX, if that's the case. Because with JSX, you can treat a JSX expression just as any other value, and pass it around just like any other data. But this, it seems like it's all outside of that. Just like in JavaScript, an if block can have an else block. And we have colons now. Interesting. Colon else. P count is between 0 and 10. A hash character always indicates a block opening tag. A slash character always indicates a block closing tag. A colon character, as in colon else, indicates a block continuation tag. Don't worry, you've already learned almost all of the syntax Svelte adds to HTML. Well, something happened here. I don't think that's what you want. Clicked. And there we go. And I don't think we actually, I don't think we tried this one out. And that's what that does. Okay, but this makes sense. You have an opening with a sharp, with a hash, and then you continue with a colon, and then you end with slash. I feel like I've seen that in some other templating engine, or templating syntax. I don't remember which though. I don't think this is new to Svelte. Multiple conditions can be chained together with an else if. So we can do that here. Colon else if count is less than 5. Then we render the inside of this. P count is less than 5. We end that. So we have an if-else chain here. So if count is greater than 10, we render this. Otherwise, if it's less than 5, we render this. And if it's neither of those, then we render this. And then we change this so that it makes sense. And so we expect to see until we get to 5, so 0 to 4, we render count is less than 5. And then from 5 to 10, we render this, and then greater than 10, we render that. 2, 3, 4, and then we expect it to switch over. And then we expect it to switch over once more. After that, yes. It's greater than 10, so it won't switch at 10. Alright. Each blocks. When building user interfaces, you'll often find yourself working with lists of data. In this exercise, we've repeated the button markup multiple times, changing the color each time, but there's still more to add. They all look the same, with the only change is the color. And then we have the rest of these colors here. Instead of laboriously copying, pasting, and editing, we can get rid of all but the first button, then use an each block. There is a programming guideline called dry, don't repeat yourself, and it is very applicable here. Because repeating yourself means that it's difficult to make changes that should apply to a bunch of related things, because then you'd have to change it to every one of them. If you abstract things, if you abstract code into something like an each block, where you only have to specify it once, then that means you can change things once, and it'll apply to everything that you want it changed to. So let's do that. Each colors as color. Then we wrap this inside of an each. Can I? Yes, I can. Okay. Very good. Okay. So we have colors here: red, orange, yellow, green, blue. And then we can get rid of the rest of these buttons here. The expression Colors in this case can be an array or array-like object. It has a length property. You can loop over generic iterables with each, and then spread the iterable into an array. Obviously, the iterable here, if this is the case, should be finite. It should end, which makes sense because otherwise you wouldn't end up rendering anything anyway. So we're partway there. We have all the circles that we need, but they're all red because we've hard-coded red here. So now we need to use the color variable in place of the red string. So we have a color here, a color here, color here. I wonder how you can escape this actually. Maybe it's interesting. They haven't told us about how to escape the if your string contains curly braces, how do you escape that? I guess you do just do this then. Okay. You can get current index as a second argument, like so. And this is really reminding me of something. I can't place my can't place it because a lot of other languages and templating syntaxes do this as well. And so we have I as our index. We can use that as a variable, I plus 1. And I assume this is probably also color and I are probably all scoped down to this block here. And they won't be usable outside. So we have 1, 2, 3, 4, 5, 6, 7. And we can click on these because we have the on-click selected color equals color. And we have aria current selected is equal to color, which we have a style for here with a box shadow. So that's why it looks like that. Okay. Keyed each block. By default, when you modify the value of an each block, it will add and remove items at the end of the block and update any values that have changed. That might not be what you want. It's easier to show why than to explain. Click the remove first thing button a few times and notice what happens. It does not remove the first thing component, but rather the last DOM node. I'm not sure I understood what that says. So apple, banana, carrot, donut, egg. We attempt to remove the first thing. It removes the last DOM node. So remove the egg, and then it updates the name value in the remaining DOM nodes, but not the emoji, which is fixed when each thing is created. Let's have a look at this code here. On click, remove first thing, and then each thing says thing. We have the thing name equals thing.name. Thing.name being that, which seemingly updates. So we go into thing.svelte, we have the emoji. Let the name is updated whenever the prop value changes, but the emoji variable is fixed upon initialization because it uses const instead of the reactive declaration. So this never gets updated afterwards. Makes sense. Instead, we'd like to remove only the first thing component and its DOM node and leave the others unaffected. To do that, we specify a unique identifier or key for each block. Each thing says thing ID. Oh, no, don't do that. thing.id. And so I guess this here tells Svelte what the key is. And so the key here is a unique identifier among siblings in the list. So here, thing ID is the key, which tells Svelte how to figure out which DOM node to change when the component updates. And so this is similar to the key in React, where it says that this is the node on corresponding updates that corresponds to a specific element. And so instead of doing everything by position, it does things by key instead. And so it matches up the key instead of matching up the positions. And so by doing that, it does what we want it to. In React, it's almost mandatory to put a key whenever you have whenever you do a loop to prevent this kind of thing from happening. So I wonder if that's recommended in Svelte, where you just always have a key. You can use any object as a key. Svelte uses a map internally. In other words, you can do thing instead of thing.id. Using a string or a number is generally safer, however, since it means identity persists without referential equality, for example, when updating with fresh data from an API server. Yeah, a string or a number, perhaps a symbol sometimes. And that makes sense because if the recommended way to update things is to update the reference, then the references will change. Strings and numbers, and I'm going to add symbols here, they are primitives, and so they don't change as long as they have the same value. And so that's why it's safer. In React, I think you can only have keys on as strings. I'm not sure if you can do objects, but even in Svelte, it seems like if you have strings or numbers, yeah, something like that. Maybe it is arbitrary in React as well. But as it says, it recommends that we use a string or a number because that is safer. Okay, so now we can test this out actually. We remove the first thing because Apple is our thing.id, which is the number. So these are all associated with a key, being the ID. And so we expect that ID1 to match up with ID1 on the next render, ID2 to match up with ID2 on the next one, and so on. And so we should only see Apple being removed because we have things.slice equals 1, which chops off the first elements, like so. Alright, await block. Most web applications have to deal with asynchronous data at some point. That is true. If you're working with any sort of API and you're calling out to an API, you will need to do that. On occasion, playing certain things or like doing certain things in the browser, like playing audio or playing video or something, that might also be asynchronous. Svelte makes it easy to await the value of promises directly in your markup. So await promise, and we have here waiting here. As we do this, we're not going to get anything because it's asynchronous. Get random number in the utils function is an async function, which means it's asynchronous and it returns a promise. Await fetch random number, and this is an API call, and so that's why it's asynchronous, because we need to wait for that request to come back. Okay. So that's the util. We just import it as any other regular JavaScript function, or yeah. And so we can await this. Await promise. Then number. The number is number. And catch error. E style equals color reds. Error.message slash wait. Number is 61. Okay. So we await on promise. So promise is get random number. Our get random number returns a promise, and a promise is something that eventually returns a value. Or as the name implies, it promises to return a value eventually. And so we wait on that, and once it resolves, then we get the promise value. In this case, we call it number, and we can pass it in as number. Or if the network call fails, we can simulate that. Then we do this. So we go to the network tab because there's a get here, and this is through service worker. What we can do is we can block the URL, and we should see that it fails, and then we render this catch here. There we go, it failed, and we get network error when attempting to fetch resource. And I get rid of that. Only the most recent promise is considered, meaning that you don't need to worry about race conditions. If you know that your promise can't reject, you can omit the catch block. You can also omit the first block if you don't want to show anything until the promise resolves. So await promise, then a number, which gets rid of this bit. And then we can get rid of this bit. We don't want to handle our errors. Did I leave that blocking? 400. Okay, whatever. So we saw nothing, and then we have this. So I'm starting to feel a little bit iffy about this template syntax. It just feels like because it's not JavaScript, it has to have another way around it, which I understand it does. It just feels kind of off. Nothing major though. As we've briefly seen already, you can listen to any DOM event on an element such as click or pointer move with the on directive. And so we have the div on pointer move equals handle move. Now the handle move function that takes a mouse, or what is presumably a mouse event, and m.x equals event.clientx and then client y. M is just a value or an object that has x and y initialized to 0. And then we have a style position fixed containing the entire thing in here. Then on pointer move, we do handle move, and the pointer is at mx and my. I'm not sure why this isn't working. I mean, it is correct because we do have a reset here. I do wonder if No, I'm using a version that should support it. There it is. Interesting. Okay. Yeah, this is pretty straightforward. Any event listener, or any event rather, I assume it basically just takes this and puts it on, it passes it to add event listener or something like that. Inline handlers. You can also declare event handlers inline. So instead of handle move out here, we can do handle move in here. I'm gonna give that an E. And have M equals X line X, Y equals E dot client Y. What am I looking at? This, yes. Spacing is a little bit off, but also it doesn't really matter. That's what they want. I want a semicolon. One, two. And they also want this on that. And then they want to get rid of this. I don't know why this isn't. Shorthand property assignments are valid. Right. There we go. In some frameworks, you may see recommendations to avoid inline event handlers for performance reasons, particularly inside of loops. That advice doesn't apply to Svelte. The compiler will always do the right thing, whichever form you choose. Performance reasons being it creates a new, new function every time. In this case, it seems like Svelte is smart enough not to do that, which is nice because it means that we don't have to think about that, all the low-level stuff, and just write the code. Just seeing where we are here. I've still got a bunch of stuff for part 1. We're probably going to go through part 1, maybe a bit of part 2. I'm not sure. We definitely won't be able to go to part 4 though. DOM event handlers can have modifiers that alter their behavior. For example, a handler with a once modifier will only run a single time. So that is interesting syntax. So if we click again, this will happen more than once. But if we do the once modifier, then that means that we click once, and then we attempt to click again, and it doesn't do it, as you would expect. So the full list of modifiers, we have prevent default calls event.prevent defaults before running the handler, useful for client-side form handling, for example. This is pretty common, I'd say, especially when you want to do a lot of custom stuff. Client-side form handling, for example, if you want to do something on submits, or if you want to prevent enter from submitting the function or the form or something like that. Or if you have a fancy, say, autocomplete or fancy input of some sort that has some sort of custom handling, you might want to do prevent defaults. Stop propagation calls stop propagation, preventing the element from reaching the next element, or the event from reaching the next element. Events in JavaScript and the DOM what it does is it goes up from the top of the documents tree down to the element that activated it, and then it goes back up. So stop propagation will stop it from going back up. Or possibly, yeah, possibly down if you catch it on the way down. Passive improves scrolling performance on touch wheel events. Svelte will add it automatically where it's safe to do so. So it seems like it's probably smart enough to understand when. So touch and wheel events, because they fire very quickly and often. And if you do it wrong, then scrolling will feel very sluggish. And so you want to do it, you want to try to do it in a passive way, so that it doesn't feel sluggish. Capture fires the handler during the capture phase instead of the bubbling phase. And so this was what I mentioned earlier, where the event will go down the tree and then go back up. The capture phase is when it goes down, the bubbling phase is when it goes up. By default, events are event handlers attached to the bubbling phase, so on the way up. But on occasion, it might be useful to go on the capture instead. Once, remove the handler after the first time it runs, so as we see here. Self only trigger handler if event.target is the element itself. So not when it goes down or when it goes up, but at the inflection point. So if I click, so for example, if we do a div here, and we have on click equals alerts div, let's just say div, and so without, what is it explaining about here? Visible non-interactive elements in the on-click event must be accompanied by an on key down, key up, key press. Sure, I don't really care about that right now. And so, what we expect to see is that we get clicked, and then we expect to see another alert that says div. We get clicked, and we have another one that says div, like that. If we do capture, then we expect to see div first, and then we get clicked. Like so. Or we do self. Actually, I think we're going to need to make this a little bit bigger. With, say, 200 pixels. Border equals 1 solid black, just so we can see it. And so if we click on the button, then we expect to see only clicked, because it's not the div that was clicked. But if we click outside, then we do expect to see div. If we click on the button, we have clicked, but no div. We click outside of the button, then we expect to see no button, no clicked, but yes div. Like that, because it's so. Trusted. Only trigger handler if event.is trusted is true, meaning that the event was triggered by a user action, rather than because some JavaScript called element.dispatch event. So I didn't know that this was actually a thing, but okay, interesting. You can chain modifiers together, click once capture. So we can try that. Once self. So we can have it. Interesting. That didn't actually fire. Maybe the order matters? Ah, okay. No, interesting. So I guess it's once, so it fires. So as well, I guess attaches a handler to it, but it wraps the handler. What it does, then it seems, is that because it has been called and it failed the self check, it just didn't run the handler that we provided, but it still ran a handler, and so it detached the handler that it applied. I don't know if this is what I would expect it to do, but that is a valid way of looking at it. Okay, so that's something to keep in mind. In React, you'd have to do all this checking yourself. So prevent default, stop propagation, whatever. Those you would explicitly have to call inside of your handler. Which I think is something you can do here in Svelte too, because you can take an event in your event handler. But I guess this is for convenience, because then you can just have it here, and it's clearer in a sense what you expect it to be on site, rather than inside the function. You have to do certain things, and it's not obvious from here that you say you only want it to happen once and all that. Actually, come to think of it, how do you do the capture or React in React? Something I'll have to look up sometime. Component events. A component can also dispatch events. To do so, they must create an event dispatcher. Update inner.svelte. We have import create event dispatcher from Svelte. Once dispatch, well, let's create event dispatcher. And then create event dispatcher must be called when the component is first instantiated. You can't do it later inside of, for example, set timeout callback. This links dispatch the component instance. So basically it has to be this. You can't do it later. Then add an onMessage handler inside of app.svelte. OnMessage equals handle message. You can also try changing the event name to something else. For example, change dispatch. Actually, let's test this out first. Click to say hello. What happens? We have inner rendering a button that says on click say hello, and we dispatch the message event with the hello. With an object that has a property called text that has the value hello. And inside of app.svelte, we have a message or an event handler that does this, where it does an alert on event.detail, which I guess this is the detail. And we reference a property text there. So we expect to see an alert with hello. And we do. In React, all you do is pass down functions as props. We don't really deal with events in React, I think. But I think this might be useful because I guess there's some sort of magic or something that happens with event handlers. Something special happens, and you can chain the all those modifiers as well from here. So I suspect that it's more idiomatic in Svelte to, I guess, use events, like actual events. So you can also try changing the event name to something else. So instead we can do greet. And so because message is not greet, it doesn't do anything. But if we change on message to greet here, then it matches, and we should see the alert box. Maybe we only do the part 1. My voice is starting to die. Unlike DOM events, component events don't bubble. Okay, interesting. If you want to listen to an event on some deeply nested component, the intermediate components must forward the events. In this case, we have the same app.svelte and inner.svelte as in the previous chapter, but there is now an outer.svelte component that contains inner. So app renders outer, which renders inner, which renders the same inner stuff that we had before. One we could solve a problem is adding create event dispatcher to outer.svelte, listening for the message events, and then creating a handler for it. So import inner, we're looking at outer. Import inner, create event dispatcher, the same thing as before, and we do forward. But that's a lot of code to write, so Svelte gives us an equivalent shorthand. An on-message event directive without a value means forward all message events. On message, and I guess this is why you want to use events rather than prop callback, is because you have forwarding. And so forwarding here, it looks like it's it kind of mimics how the DOM works, like DOM events work, where it bubbles up, and that can be useful. I wonder what the rate of collisions is for something like this. But it does seem like it allows you to work in a way that treats DOM events and component events as similar. DOM event forwarding. Wait, sorry, let's see that in action. So click to say hello. We forward the message, and then we do the same event handling here. So we should expect to see our alert box. Whereas if we reset it, because we're not forwarding the events here, it stops here, and we don't get anything. I don't think there's any such forwarding in React. I think you'd have to so either you'd use a context and call some sort of callback from the context, or you do a lot of I guess prop drilling, something like that, where the outer component takes in, say, an on message prop, and then that gets forwarded down to the inner component, which also takes an on message prop, and then the inner component, when it's ready to fire, calls that on message prop. It's a little bit clumsy, but it works. Oh, this does seem a little more elegant though with the events. Event forwarding works for DOM events too. We want to get notified on clicks on our big red button. To do that, we just need to forward click events on the button element in bigredbutton.svelte. So we have app, we have an on click, handle click, and then we have this button where if we don't forward anything, the DOM event does not bubble up. Wait, what? Okay, so I see. It doesn't recognize it there. That's interesting. So normally if you have a... normally you would expect the DOM event to bubble up on this layer. Now this is why you don't get collisions, because this seemingly treats this component as one big thing. So we handle click, but it's all internal to the component, and it doesn't reach outside of the component. And so if you want it to reach outside, then you have to forward it. I think that's going to take a bit of getting used to. Okay. I wonder what the rationale behind that is. It's probably to keep things encapsulated and avoid surprises. It's probably something you end up just getting used to. Bindings text input. As a general rule, data flow in Svelte is top-down. A parent component sets props on a component, and a component can set attributes on an element, but not the other way around. Sometimes it's useful to break that rule. Take the case of the input element in this component. We could add an on-input event handler that sets the value of name to event target value, but that's a bit boilerplatey. It gets even worse with other form elements, as we'll see. Instead, we can use the bind value directive. This means that not only will changes to the value of name update the input value, but changes to the input value will update name. So to do bind value name, then actually let's reset that. So looking at the code here, we have name as world, where we have name going into the value of the input, but also the text here. We do a bind. That means we get two-way. If we type in here, it gets updated here. So the data flow is out from the inputs into the name variable, and then back out to the text here. This is a little bit more elegant than in something like React, where React, the way that it prefers to work is that though there is no data binding in React, it is all top down, and you use something. The word there is controlled component. So the component, all it does is render the props that it's given, and then it's up to the parent component to manage the data that is passed down to the prop. And it does that exactly by doing this, adding the input event handler, or in this case the input callback, to set some state in the parent component that then gets rendered back down to the input. And that is a little bit clunky, but it is something that React devs get used to, and somehow it becomes second nature. But I think this this two-way binding here is pretty elegant. I think Vue has this too. Numeric inputs. In the DOM, everything is a string. That's unhelpful when you're dealing with numeric inputs type number and type range, as it means you have to remember to coerce input.value before using it. With bind value, Svelte takes care of it for you. So we do want to bind these, so bind okay. So we have A and B as numbers. We bind A and bind B on the number and the range. And then we have A plus B equals A plus B. So if these were strings, then A plus B would be the two concatenated, but because they're numbers, we will do proper addition on them. Like so. The same goes for the number inputs here. I do want to find out though, because it does seem like it's doing some sort of analysis. It knows that it's an input element. It knows that it's a type number and a type range, and so it knows that the value here should be changed to a number. But is it smart enough to do let's say number equals number? Is it smart enough to know that if you give it a variable, will it still do the same? I suspect it will. Type attribute cannot be dynamic if input uses binding. That's how they get around it. I see. So in cases where it's dynamic, then I guess it has to be. You have to take the on inputs. Yeah, you have to listen on input and then not use binding. Okay, oh, that makes sense. So the way it knows that it has to turn into a number is because it's not dynamic, it's static. Checkbox inputs. Checkboxes are used for toggling between states. Instead of binding to input.value, we bind to input.check. So, similar case here. We do a bind. So I guess in that case then, bind only works on specific things, properties, attributes. I guess this is a list of. Okay. You must opt in to continue if you're not paying your the product. We will bombard your inbox and sell your personal details. Yeah, as the saying goes, if you're not paying, then that means you're not paying for a product, you are the product. Being your personal details and whatnot. Okay, select bindings. We can also use bind value with select elements. Select being the drop down here. Bind value selected on change answer equals. Interesting, okay. Oh no, that makes sense. Note that the option values are objects rather than strings. Svelte doesn't mind. Questions here being these ones. Question.text. So that's convenient. I don't know how this ends up rendering on the DOM, but it's nice to be able to have. It's nice to be able to have objects, because then you can do things like selected equal or like selected as an object. That's good. That's good. Because we haven't set an initial value selected, the binding will set it to default value automatically. Be careful though, until the binding is initialized, selected remains undefined, so we can't blindly reference selected.id in the template. Makes sense. I do want to see how this is rendered in the DOM. Okay, interesting. So, I guess Svelte just knows that that the value is like it does some stuff in the background that it knows that it's the actual value that you want. But if you were sending this as a form, as is, you might not be able to get away with that. I I guess we'll see how form handling works in Svelte. Button disabled is no answer. Type submits. Okay. Well, selected. Where do we get selected from? Selected question. Selected. Where do we assign selected? Ah, yes, right. Okay, bind value is selected. That makes sense. Group inputs. How far in are we? Okay. That's not too bad. I'm gonna take another drink of water. Yeah, there are some streamers who can go for multiple hours just talking the entire time. I don't know how they do it. Like we're at 2 hours and I'm already starting to lose it. If you're playing a game where you don't talk as much, then I guess that's guess that helps. If you have multiple type radio or type checkbox inputs relating to the same value, you can use bind group along with the value attributes. Radio inputs in the same group are mutually exclusive. Checkbox inputs in the same group form an array of selected values. Add bind group scoops to the radio inputs. This here. Oops. Yeah, this is where it's starting to feel a little bit, because it's not JavaScript, you end up having to do a lot of extra syntax stuff that you have to remember. I guess it's a trade-off. Yeah, scoops there being this variable scoops, I guess. Where this has the... So yeah, instead of binding the value, you're binding group because it's the inputs, you have multiple inputs with the same name, and then group would take on the value. In this case, 1, 2, or 3. Okay, that makes sense. Whereas we have in the checkboxes group flavors. With a U. We initialize that to an array. Maybe we'll end in 30 minutes. I just got a notification that Aki Kazuki from Pixel Link is going to learn the kalimba. Kind of want to say that. I was playing the kalimba during the recursive stream last week. I do need to tune mine. I think the higher notes have gotten a little bit out of tune. But yeah, we should be able to finish all of this in half an hour, I think. So bind group flavors, and so flavors is an array, which is what this will end up being. Formatter. Ooh. Nice. So this is what gives us our AND conjunction. Interesting. No, this is the proper way to do it. Anyway, you'll see it. So what does this do? So if number is one, we have scoop or scoops. And then we have cookies and cream and chocolate chip, all this stuff here. If flavors.length is equal to 0, please select at least one flavor. We have here. You ordered 1 scoop of cookies and cream. Sorry. Hold on. And then else if flavors.length is greater than the number of scoops, so we have more flavors than scoops, then we can't order more flavors than scoops. Else, you ordered scoops of whatever flavors. We have 2 scoops. We have 2 scoops of cookies and cream, or we have cookies and cream and mint chocolate chip. And this intel here, list formats. I didn't know this was a thing, but it's good to know that it is a thing. We have the conjunction being the and there. Yeah, that's nice. And this is all just built in JavaScript, by the way. Intel. The internationalization object. Select multiple. A select element can have a multiple attribute, in which case it will populate an array rather than selecting a single value. Replace the checkboxes with a select multiple. So here we select multiple, and we bind value flavors. And then get rid of the rest of these. And inside, I guess we get rid of this label too. Man, I wish I had Vim. We have an each. Nope, don't not want to go all the way down there. I wonder if there is a way. I guess not. Where is my cursor? You have your closing each, and then inside you have an option with flavor inside. And then we close the select. I'm gonna get rid of all this empty space, get rid of this label. I guess this prevents us from writing bad HTML too. Or malformed HTML. Note that we're able to omit the value attribute on the option since the value is identical to the element's contents. So we have cookies and cream, mint chocolate chip, raspberry ripple, and we can hold control to select more than one. And otherwise it's the same as before. Very good. The text area element behaves similarly to a text input in Svelte. Use bind value. Interesting. You would put value here instead of inside here. Ah. In cases like these where the names match, we can also use the shorthand form. Like so. Good to know. It applies to all bindings, not just text areas. Shorthands are nice. And so we have this text here. Whereas before, we had this where value equals value. And our bind lets us do this, whereas if we didn't have a bind, it would just change input, but not this bit here. Okay. Next, life cycle. Every component has a life cycle that starts when it is created and ends when it is destroyed. There are a handful of actions that allow you to run code at key moments during that life cycle. The one you'll use most frequently is onMount, which runs after the component is first rendered to the DOM. In this exercise, we have a canvas that we'd like to animate using the paint function in gradient.js. This here, we don't really have to think about what's in there. Begin by importing the function in Svelte, or from Svelte. Import onMount from Svelte. Then add a function that runs when the component mounts. So we use onMount, and it takes in a callback. Fonts canvas equals document query selector. Remove this? Yes, I can. Okay. Query selector canvas. Yes, I was thinking about this. Learn how to get an element reference without using the document query selector. Because this will, if you have multiple canvases, and this isn't the first one, it'll probably reach out and get the wrong one. Const context equals canvas get context equals 2D. Request animation frame function loop p request animation frame loop paint context t. Okay. So it's looping through that. After mount, it does that. Because if we don't do onMount and we just do it right away, it's going to fail because there's no canvas. And so it just fails. Or console uncaught reference errors C or context is not defined. Interesting. In any case, it fails. One problem, the loop will continue even after the component has been destroyed. To fix that, we need to return a cleanup function from onMount. I've pressed the solve button, so it's okay. Let frame equals that. Frame equals request animation frame, and then we return a cleanup function from that, which will get called once we unmount. We cancel animation frame, all the cleanup stuff here. So this feels similar a little bit to React's. Well, React class components have an onMount function, but in React function components, you have a use effect with an empty dependency array. And use effects also have cleanup functions. And in that case, the cleanup function will be run the next time that the use effect runs, or when the component unmounts. And in the case of a use effect that has no dependencies, it only ever runs once, so it'll run the cleanup once the component unmounts. Okay, before update and after update. The before update function schedules work to happen immediately before the DOM is updated. After update is its counterpart, used for running code once the DOM is in sync with your data. Together, they are useful for doing things imperatively that are difficult to achieve in a purely state-driven way, like updating the scroll position of an element. This Eliza chatbot is annoying to use, because you have to keep scrolling the chat window. Let's fix that. Eliza is very... I mean, nowadays it's not so impressive because you have things like ChatGPT. But back in the day, I think it was... Was it the... It wasn't the 80s, it was earlier than that. 64 to 67. Yeah. But it was a chatbot that simulated conversation. It basically picked out some keywords that you have, I think, and then it spit out an answer that was somewhat relevant. But now you have AI and like large language models and whatever that are a lot more natural. So these days, if you put Eliza in front of somebody who has that kind of context and that you didn't tell them it was an old program from the 60s, they probably wouldn't be impressed. But for the 60s, it was pretty impressive. Not that I know firsthand, but I did have an encounter with an Eliza-like program when I was young, and that did impress me. So this Eliza chatbot is annoying to use because you have to keep scrolling the chat window. Let's fix that. So that's I already messed up. Do you feel strongly about discussing shit? No. Yeah, I see what you mean. Just because. Well, this definitely does feel like Eliza. Okay, so let auto scroll equals false. Where's this let div? Let auto scroll equals false. Then we have before update determine whether we should auto scroll once the DOM is updated. If div, which we have here, const scrollable distance equals div.scroll height minus div.offset height. Auto scroll equals div.scroll top is greater than scrollable distance minus 20. Wherever this magic 20 comes from. Probably just a threshold. Then we have the after update, and DOM is now in sync with the data. If auto scroll, then we have div.scroll to 0 div.scroll height. Okay. Note that before update will first run before the component has mounted. So we need to check for the existence of div before reading its property. Good to know. Yes, some troubling. You are sure? Of course I'm sure. Do you believe it is normal to be sure? Why not? Why do you ask? Am I asking? Does that question interest you? Yeah, it just goes on like this. It's kind of amusing. But we do scroll. That's nice. Note, no, we already read that. Tick. You can see that behavior in this example. No, scroll all the way up. The tick function is unlike other lifecycle functions in that you can call it at any time, not just when the component first initializes. It returns a promise that resolves as soon as any pending state changes have been applied to the DOM, or immediately if there are no pending state changes. When you update component state in Svelte, it doesn't update the DOM immediately. Instead, it waits until the next micro task to see if there are any other changes that need to be applied, including in other components. Doing so avoids unnecessary work and allows the browser to batch things more effectively. Now in JavaScript, there is this thing called the event queue, and there are ticks at which events occur. And when you schedule an event, on the next tick is when the event, or the next event in the queue, is processed. So if you don't schedule an event, then what happens is that it all runs synchronously, and it holds up updating the display, which can make your web page feel like it's locked up. But instead, if you do wait for if you do a lot of your heavy lifting asynchronously by scheduling events, then you can prevent the UI from locking up. And batching things up like this means that you don't end up doing one thing and then reflowing the page, and then doing another thing, and then reflowing the page yet again, and then doing yet another thing. You do everything at once, and then the page reflows once. Okay. I don't know if we're going to be able to finish this. Maybe we will. But also my voice is starting to give. Alright, we'll speed through it. When you update the component state in Svelte, it doesn't update the DOM immediately, instead it waits until... No, we already read that. You can see that the behavior in this example, select a range of text and hit the tab key. Because the text area value changes, the current selection is clear and the cursor jumps annoyingly to the end. We can fix this by importing the text. So if we select some text and then hit tab, you toggle uppercase. Ah, I don't know you can do that. How does it do that? And selection start, selection end, just... Ah. You get selections from text areas. I didn't know that. Okay. Fix this by importing tick. So we have import tick. Tick from Svelte. And running it immediately before we set this dot selection start and this dot selection end at the end of handle key down. Right here, await tick. And so this forces it to go on to the next tick. I suppose one potential way to do this, so actually if we try this here, then we keep the selection. I suspect an alternate way to do this is to do set timeout, which also will wait until the next tick. But maybe it isn't exactly equivalent. I'm curious how this turns out though. Oh, okay, it's the same. Yeah, probably pretty similar. I think it's nice because it's all built in. And then you don't have to wrap anything. Very good. Okay. We only have a few left. And then we'll end it after part 1. Writable stores. Not all application state belongs inside your application component hierarchy. Sometimes you'll have values that need to be accessed by multiple unrelated components or by a regular JavaScript module. In Svelte, we do this with stores. Store is simply an object with a subscribe method that allows interested parties to be notified whenever the store value changes. In app.svelte, count is a store. And we're setting count value in count subscribe callback. For stores.js, we have a count, we have writable, and store, we have 0. Which means that set and update methods in addition to subscribe. Now in incrementer.svelte, wire up the plus button. Oh, there's plus here. Count.update n plus 1. Clicking the plus button should now update the count. Do the inverse for a decrementer. Count.updates n minus 1. Finally, in resetter.svelte, implement resets. Count.sets 0. Resets. Very good. So I guess this is what I was saying about having a lot of this stuff built in. Stores, I guess, being one of them. Which in a way is nice, but also it feels like maybe it's doing too much. But maybe because it has it built in, it has the ability to inspect certain things, and then it knows to update things. Maybe. Now, Svelte being triggered, or updates in Svelte being triggered on assignments, it means that updating wouldn't actually work without this, I think. So I think it does have to know that the value is being updated. Yeah, so I think it has to do that. Interesting. Okay. In React, you'd probably have something like a context for this. But this does feel like, because you can use it outside of the components, this is probably a little bit more powerful. I think I had seen something similar for React. Somebody wrote something. What was it? React? Do they call it atoms or something? I don't remember. But it was something similar, and I do like this idea. Auto subscriptions. The app in the previous example works, but there is a subtle bug. The store is subscribed to, but never unsubscribed. If the component was instantiated and destroyed many times, this would result in a memory leak. Start by declaring unsubscribe in app.svelte. Const unsubscribe. Calling a subscribe method returns an unsubscribe function. You now declared unsubscribe, but it needs to be called, for example, through the onDestroy lifecycle hook. Import onDestroy from Svelte. Unsubscribe. Starts to get a bit boilerplatey though, especially if your component subscribes to multiple stores. Instead, Svelte has a trick up its sleeve. You can reference a store value by prefixing the store name with $. So instead of doing all of this, I'm going to use $count. Okay, so $variables then mean that or rather dollar variables are special. Auto subscription only works with store variables that are declared or imported at the top level scope of a component. I wonder where you wouldn't have a top level store. You're not limited to using $count inside the markup either. You can use it anywhere in the script as well, such as in event handlers or reactive declarations. Any name beginning with $sign is assumed to refer to a store value. It's effectively a reserved character. Svelte will prevent you from declaring your own variables with a $$ prefix. Sensible. I wonder what that means for jQuery though. jQuery is often alias to $. But it does also export the jQuery like as jQuery, so maybe it's not an issue. Readable stores. Also, wait, no, go back. Unsubscribe. Well, do you not unsubscribe to me? And if you aren't to subscribe, you should subscribe. Not all stores should be written by whoever has a reference to them. For example, you might have a store representing the mouse position or the user's geolocation, and it doesn't make sense to be able to set those values from outside. For those cases, we have readable stores. OpenStores.js, the first argument to readable is an initial value, which can be null or undefined if you don't have one yet. We have readable. Actually, what did a writable store look like from before? Okay, it's called writable. So we have a readable store. First argument to readable is initial value, which can be null or undefined. Second argument is a start function that takes a set callback and returns a stop function. The start function is called whenever the store is it gets its first subscriber. Stop is called when the last subscriber unsubscribes. Ha. Okay. How do you interact with this then? How are you supposed to write to this? You can't set it from outside. Okay, no, you have sets. This feels like a little bit of gymnastics to be able to use this. But maybe, maybe I'll see it when, like, for example, if you have yeah, I don't know. Maybe some sort of listener. New dates. Const interval. We'll set interval. So every second. Clear interval. Interval. Yeah, so this here definitely feels like a very large abstraction. Makes me feel a little bit uneasy, but so far it's still somewhat logical. I think it's just something I'll have to get used to. Derived stores. You can create a store whose value is based on the value of one or more other stores with derived. Building on our previous example, we can create a store that derives the time the page has been opened. So we have time elapsed as our stores, and then we have const elapsed. Inside of stores.js, we have derived here. We have time math.round time minus starts divided by 1000. Where we get time is this store here. The one that we wrote earlier, the date. And then we have start being the start time. And then this will continuously update. Okay, that makes sense. And then here we do some math to say how much time has elapsed since we had opened the time. And then we round it off, and then we take, because this is in milliseconds, we want to take the seconds, and then we round it off to the nearest whole number. It's possible to derive a store from multiple input stores and explicitly set a value instead of returning it, which is useful for deriving values asynchronously. Consult the API reference for more information. I'm not entirely sure what the use case is for this one, but I'm sure it's one of those things where if I need it, I'll know I need it. Custom stores. As long as an object correctly implements the subscribe method, it's a store. Beyond that, anything goes. It's very easy, therefore, to create custom stores with domain-specific logic. For example, the count store from our earlier example could include increment, decrement, and reset methods and avoid exposing set and update. Return. We have stores, create count. We take in a writable, so we have writable do our thing for us. We have subscribe, set, and update, so it is our backing store. And then we add in our own things. We have updates and n+1. I'm gonna do that first. So it doesn't keep flashing. And -1. And sets 0. Okay. No, I think I like this idea. Because it means you can expose your own interface. Reminds me a little bit of Redux. Where you have a central store and then you have actions, where these are essentially your actions that modify the store. And then these end up being your reducers. Store bindings. Yeah, this is the last one. If a store is writable, i.e. has a set method, you can bind to its value just as you can bind to a local component state. In this example, we're exporting a writable store name and a derived store greeting from stores.js. Update the input element in app.svelte. So the name is a writable store. We bind to this. And so then our thing updates. Change the input and update name and all of its dependents. We can now assign directly to store values inside of a component. Add an on-click event handler to update the name. On click. We give it a callback. $name for our writable store plus equals exclamation mark. What do you want? Yes. Click outside or fix the code to dismiss. Am I missing something? Button on click equals. You need an equal sign. Okay. So it has some sort of shorthand here where it says an assignment is equal to, or it's the same as a set. Very good. Okay. So I think this here makes things a little more convenient to work with, because then it basically, we can basically just treat the store as a variable, including any kind of assignments to it. Okay, and that ends part 1. I think that's as far as I can go with my voice. Hold on. So, closing thoughts, and I think we will go through the rest of the tutorial at some point. Definitely before. I think we'll want to go through maybe part 2. What's in here? I'm not sure we necessarily need any of these parts. Yeah, we might not need these parts for Owl Fudge, because I think we might be able to get by with just the basic Svelte. But I do want to go through these bits eventually. So I guess expect 3 more streams on learning Svelte and sveltekits. Even though Owl Fudge will probably only end up using most of part 1. And then I will have to pick up enough of sveltekits to... Well, actually, maybe we'll go through sveltekit before we do Owl Fudge. I don't know. We'll figure something out. But yeah, expect more just Svelte learning streams, because we have 3 more parts to go through. Sorry, I'm just trying to get something here. Yes. But yeah, that's it. My voice is dying. I think I'll rest my voice and then eat or something. Hope I still have a voice tomorrow. I'm sure that's not going to be an issue. Like I mentioned, Raki Kazuki is going to be learning the kalimba. So I will be there. If you wish, you can also hop on there. I can't do any redirects because I don't have enough followers. I think you need 1,000 before you can raid people. But yeah, I will be checking that out while I go have dinner or something. In the meantime, for this Svelte stuff, I hope you learned something. It was for me, it was pretty insightful. I think perhaps, I mean, Svelte might not be the maybe I put it up a little bit too high on a pedestal, and I'm seeing all the nitty-gritty parts of it where it feels like there are certain abstractions that feel like kind of maybe not boilerplatey, but in the ideal case it might be something that I'd want to avoid when designing, if I were to design my own kind of framework. But I can see why they would need these, and so I can't really fault them for it. I'm still very interested in Svelte, and I think for now, I think it does feel like something that I would prefer over React, but that remains to be seen for when I actually do something in it. But yeah, Owl Fudge and probably the website and the schedule are probably going to be written in Svelte. Website and schedule being rewritten in Svelte at some point, because that needs to be updated. And it's probably better. It's going to be better than whatever handwritten stuff that I have there. The website actually is currently written with a static site generator called Zola, and I've had to fight the templates to get it to do what I want. So I figured it'd be easier to just rewrite it in Svelte or some other front-end library. But yeah, there we go. Like I said, hope you learned something. I learned something. And keep this in mind because we will be using it sometime in the future. Tomorrow, we will be playing chess. And as you know, as you might know, chess is somewhat infamous in the VTuber sphere. Because of one certain game between Takanashi Kiara and Amelia Watson. I do hope that I will be playing better than them though. So come check that out. In the meantime, if you're in the Discord, you should go and join the Discord. The link is in the description. And if you want to go through the Svelte tutorial yourself, the link is also in the description. And so feel free to go ahead and do more than just the part 1. Okay, that's it. I think I gotta stop talking. Thanks for coming, everyone, and good night. See you next stream.